pre-algebra students. Today is the ASVAB test, so there's no one here in the room with me. If you took the ASVAB test, I wish you the best of luck. I hope you're feeling good about the test, but at the end of the day, don't stress too much about it. It can only help you with graduation. But because I'm here alone, I'll be talking directly to you at home today. Our lesson today is going to be on order of operations. The first 3 lessons in this class review some of the things we learned last quarter back in developmental math. So the first lesson was reviewing some stuff we learned about integers. Yesterday's lesson was reviewing decimals and fractions. This will be the last of these review lessons in which we will review order of operations. Before we get started with that, I've got these 6 questions here. If in a moment you want to pause your video and try these 6, they'll be review questions that will help get us ready for what we're learning today. All right, so this first one here, when you have 2 numbers next to each other in parentheses, that means multiplication. So this means 3 times -11, which would be -33. If you're multiplying different signs, the answer is negative. Number 2 is the square root of 81. We're looking for what number multiplied by itself gives you 81, and that number would be 9. This next one here, there might be a middle step I do before getting my answer. If you see 2 negative signs like that right next to each other, subtracting a negative is the same thing as adding 2. You can think of it using that rule or think of it as a negative times a negative gives you a positive there. After we do that, I've got different signs, so I am subtracting and keeping that negative sign on the larger number. This next one here, I would read this as 2 to the 4th power. The biggest mistake students make is they think this is 2 times 4, but that's not what this small number here, your exponent, tells you. An exponent tells you you want to multiply 2 by itself 4 times. When I do that, 2 times 2 gives me 4. 4 times 2 gives me 8. 8 times 2 gives me our answer of 16. This next one here, we learned that like slash line means division. So this means -9 divided by -3. That would give me 3. If you're multiplying or dividing the same sign, your answer is positive. And then this last one, it's similar to back up here in number 4. That is another exponent. So that is telling me I want to do 7 times 7. I read this one, by the way, as 7 squared. If that exponent is a 2, you say squared. Math 7 times 7, and our answer is 49. What we're going to be seeing in today's lesson is going to have a little of all of this. I'll go ahead and erase this, and we'll get started with today's lesson. Remember we said it's on order of operations. We will review what order of operations is, how you use order of operations to help you in problems, but the real focus of this lesson is going to be on how you use order of operations to represent and solve word problems. When we did this back in developmental math, a lot of you showed that you're really strong at using this just for like math problems, but when it comes to reading a word problem and representing that word problem with one single equation, even if there's lots of steps for it, can understandably be more challenging. So that's going to be the focus of this lesson. To get us started, there's a lot of math vocabulary right there, really with that word operation and order of operation. So a quick review. When we say operation, there are 4 operations in math. Do you know what those 4 are? So the 4 types of math. So our 4 operations, you can write the words if you want, but I would say the 4 operations are add, subtract, multiply, and divide. So when we talk about the order of operations, we're talking about the order you do these things in. We're going to say order of operations tells us the steps, or the order, to do the math problems in, and what you should do first. One of the things with order of operations is you're not going to do every single problem from left to right. Sometimes you might be starting at the end or in the middle of the problem, depending on what operations you have in the problem, because there's a specific order you do these operations. And for problems with different operations, if you've got a problem that has more than one type of math in it that you need to do, the word we use to help us remember the order is PEMDAS. Each of these letters represents something. Depending on where you learn this, you might hear other words. I know a lot of our students are familiar with BODMAS. Some other schools use something called, what am I writing? Something called GEMDAS instead of PEMDAS. I'll touch a little bit on what all of these here mean. We'll go ahead and get started. The first thing we're going to look at is what each of those letters represents. So, again, if you want to pause this video and quiz yourself, see what you remember from last quarter, we're going to say what each of these 6 letters here represent. This first one here, P, is going to be parentheses. That means if a problem has math that you need to do inside parentheses, like right here, that would be where you want to start. Now, you remember a moment ago I said there's some other acronyms people are familiar, sometimes instead of PEMDAS, BODMAS. The B in that means brackets. So instead of calling these parentheses, we call them brackets instead. The idea is the same. The other one I mentioned is GEMDAS. And the G there, instead of parentheses, means group. Now that one's not as obvious why we would say group. But what we mean is if you have a problem where something is grouped together like that, it could be with parentheses, it could be with brackets, it could be with something else we're going to see today. That's where you want to start. So I wanted to mention this just because we're going to see problems today that use something besides parentheses, and we're going to want to start there. After P, we've got E. E was that word we were saying in our review questions at the beginning. It is exponents. So the next thing you would want to do in your problem is if there's any exponents, you want to simplify your exponents. That means in this problem right here, this part here, that 4 squared, that would be where I want to start. The next one, M and D, are going to be your multiplication or division. So I'm going to say multiply or divide next. The biggest thing I think students forget with order of operations in PEMDAS is in class, lots of times I have students who know, oh, order of operations, that's PEMDAS. They know, oh, P, E, M, D, A, S, I know what all those letters represent. But the part people forget is this part right here, this idea of working left to right. What that means is if a problem has both multiplication and division, if it has both of them, you don't always do multiplication first. It's going to depend which one is on the left side, because we're going to work from left to right. So a problem like this, it has both multiplication and division. We're going to go from left to right. So in this problem, division comes first. So I would do the division part first, get an answer, and then my next part would be the multiplication. If I switched it around, if instead it said 4 times 2 divided by 3, then if I'm looking from left to right, the multiplication comes first. So I would do that first and then do the division. So it's going to depend which one comes first in the problem. These last two are similar. A and S stand for addition and subtraction. The idea is the same. If you have both of those in a problem, you're going to work from left to right. So in this problem right here, the first thing I would do would be that addition. I would get an answer, and then I could finish with that step by subtracting. At this point in the lesson, I want to make sure you know what these 6 letters represent. If you're taking notes, I would make sure I write those 6 letters down somewhere in your notes and what each of them stand for, because we'll be using that a lot today. With that, we can get into the math. Now, I mentioned earlier when you're looking at these problems, the majority of these, you're not going to do the entire problem from left to right. You're going to be jumping around a little bit depending on PEMDAS and depending on what it's telling you to do first. Because of that, I've got a reminder here. It's really important that you only do one thing at a time. The thing I want to emphasize in this is that we're using PEMDAS in order of operations to tell us the steps. So if you're trying to do it all at once, it's real easy to make a mistake somewhere or do something out of order. But if you're only doing one thing at a time, it's a lot easier to make sure you're following the correct order. So for example, I've got this problem right here. I see there's a lot going on. I can see some subtraction. I see an exponent. I know when you've got a number next to another number with parentheses, that means multiplication. So I see a lot going on. That's going to be a clue that I want to use PEMDAS to tell me the order to do this problem. And I am writing it like this instead of, ooh, that is the letter B, instead of like this, because I find writing it like this is going to remind me of that left to right rule, and not multiplication always happens before division. Looking at this problem, do you have an idea where you would want to start? Well, here we want to check first to see, is there parentheses? There are parentheses. There's math for me to do inside the parentheses, so that would be where I want to start. The first thing I want to do is that 12 minus 6. When I do that, 12 minus 6 gives me 6. I've done one thing, so that's all I'm going to do in this line. I'm just going to copy everything else down. So I'm going to copy those parentheses, that exponent, and then the 1/2. And I'm done with my parentheses. Our next step, next is E, which is exponents. I see an exponent. There's an exponent right here. So the next thing I would want to do is do my 6 squared. Remember, 6 squared, it's not 6 times 2. 6 squared is 6 times 6, which is 36. So my next step is I'm going to do this part right here and say, well, 6 squared is 36. Now, because I want to show that multiplication there, it's important that I'm bringing down those parentheses too with my 1/2, just so it still says multiplication. And I'm alluding to what the last step is. The last thing we have to do is multiply here. I've got 1/2 times 36. Go ahead and see if you know how to do that math. One half times 36, that's something we reviewed in yesterday's lesson. One of the things that's helpful if you're multiplying a fraction is make both numbers look like fractions. So instead of writing it like this, I would probably write 1/2 times 36 over 1. Anytime you want a number to be a fraction, if it's not already, you make that denominator 1. And then to multiply, I'm just going to multiply straight across and then simplify if I can. So when I do that, 1 times 36 gives me 36. And 2 times 1, 2 times 1 is 2. I'm looking at that. I see I can simplify by dividing both numbers by 2. And when I do that, I get 18 over 1. Not my final answer, because if I was to read this, this is 18 wholes. 18 wholes is just the same thing as 18. I want to point out something here. When you're multiplying 1/2 times a whole number like 36, you can think of it as 1/2 times 36, but multiplying by 1/2 is the same thing as taking half of 36. We learned 1/2 times 36 is the same thing as half of 36. Half of 36 is 18. 1/2 is one of those easier fractions to kind of think of and maybe do in your head. So I just wanted to point that out. Another way you can think of this is just what half of 36 is, which is 18. This was the example I wanted to do with you all. I've got one here. I'm going to have you go ahead, pause your video, see if you can figure out what this one equals, and then come back to see how you did. Doing that practice is really important just because it's a way for you to check in and see where you're at. And it's a safe environment. It's a video. It's not like a homework or a test. So go ahead, pause the video, see how you do. All right. So for this one, I erased it, but I'm gonna put it back over here. We've got PEMDAS. That's gonna be what's helping me know the order to do this problem. The first thing I'm checking for is P parentheses. Now this one can be a little tricky. There are parentheses, but remember when we talk about parentheses first, we're saying, is there something inside parentheses for you to do? And here, there's just a single number. These parentheses aren't really the parentheses step. This right here is multiplication. So we're gonna do this part down here. So we're gonna say no parentheses. There are parentheses, but it's not something inside. Next is our exponents. There are exponents. So this is gonna be where I start. What did you say 4 squared equals? Did you say 16? Remember 4 squared is 4 times 4, so we get 16. I've done one thing, so I'm gonna copy everything else down. Next, we've got multiply and divide. If I look at this problem, we mentioned earlier, this here means multiplication, so that's gonna be what I do next. 6 times 2 gives me 12. I've done one thing, I'm gonna copy everything else down. So we're gonna say 3.1 plus 12 minus 16, and I've done this step. Our last one is add and subtract. Remember, if you have both, like we do here, you wanna go from left to right. So in this problem, I'm gonna start with my addition. 3.1 plus 12, remember if you're adding decimals, think of both as a decimal. So this is like 3.1 plus 12.0. That's going to leave me with 15.1. So we get 15.1 minus 16. My last step is subtracting those. If I were to write this off to the side like I did here, when it comes to subtraction, it's important that you put the larger number on top. So if I wanted to write this off to the side, I'm actually going to have to change the order to do my subtraction because 16 is larger. So off to the side, I would write 16.0 minus 15.1. When you do that, you're going to have to borrow, and that's going to leave us with 0.9. Now over here, remember the problem was actually in reverse. We still get 0.9, but I am subtracting a larger number, which means my answer should be negative. So we get negative 0.9. How'd you do? If you did great, that's awesome. If you're like, oops, I made a little mistake, I have good news. There's another practice one for you to do. The last one of these that we're gonna look at is right here. Again, go ahead, pause the video, see how you do on your own at home, and then we'll come back together to go over it. All right. In this video, I don't know why I keep erasing it, but I'm going to put it back up again. I'm going to use this to help tell me the order. We want to start with parentheses. And in this problem, there are no parentheses, but there is something we haven't seen before. That's the square root here. Remember at the beginning of this lesson when I was talking about we've got PEMDAS, BODMAS, GEMDAS, that G meaning groups. This is an example of a problem where we can think of this as parentheses, but really what it is like math grouped together. We would want to start in this problem with that square root of 16. If you got that, awesome job, because we haven't seen something like that yet in this lesson. Again, at this point you can decide. I stick with PEMDAS because that's what the majority of our students are familiar with, but if you want to start writing GEMDAS to help you remember group something like parentheses or brackets or a square root, that is all for you. You can decide what you want to do. Either way though, in this problem we're going to start off with that square root of 16. Square root of 16, remember square rooting something, you're looking for what times itself gives you 16. That number would be 4. So I'm going to write my 4 there and copy everything else down. My next step is exponents. Here there are no exponents, so that was easy. Next is multiplication and division. What did you do first? Well, in this problem, we've got both of them. Remember that rule, we want to go from left to right. So the first one in this problem that I see is division. So here I'm going to do the division first, get an answer, and then I can go ahead and do the multiplication. So here I would want to start with my 10 divided by 2. That gives me 5. I'm going to go ahead and copy everything down. And now that I've done the division, I can finish by doing my multiplication. 5 times 4 gives us 20. And I'll copy down my 4. We could always come back over here to remind me I want to do the addition, but you probably know at this point the last step is doing 4 plus 20, which would give us 24. How are we feeling about this? Hopefully you're at home saying, okay, I'm feeling okay. This isn't going to go away, but at this point we are going to shift over and look at some word problems. So we'll be able to keep practicing what we learned here, but we're going to add in an extra layer of how you can use all of this to represent a word problem. I've got 2 examples we're going to look at. The first one says, Denise wants to buy Indiana University shirts and mugs for each of her 3 family members. Each shirt costs $15 and each mug costs $10. If she pays with a $100 bill, how much change should she get? And for each of these word problems we're looking at, we're going to write an expression to represent the story. So it's going to look similar to those problems we were just seeing. And then we're also going to provide an answer to the question. Now, one of the ways you can tackle this is at this point, you guys are really good with word problems. So one way you can do this is just treating it like a word problem, going through the math, doing all the math, getting your answer, and then using your math to help you come up with an equation. That's one strategy we can use. So this one, let's go ahead and do that. Go ahead, don't worry about your equation yet to represent the word problem. Go ahead, pause the video, do all the math you want to do, and see if you can come up with an answer for the question, how much change should she get? Well, to figure out how much change she should get, there's a couple steps we're going to need to do, because to find out how much change she gets, we need to first figure out how much total money she's spending. To find the change, she's paying with 100, so we're going to have that 100. We need to know how much money she's spending to figure out how much money she's got left over for her change. So to figure out how much money she's spending, there's a couple things she's buying. It says she is buying shirts and mugs for 3 family members. So she's going to buy 3 shirts and she's going to buy 3 mugs. To find the total cost of the shirts, we've got each shirt is $15. I'm going to go ahead and label this first. So the shirts, each shirt is $15 times the 3 shirts she's buying. That gives me, she's spending a total of $45 on shirts. The other thing she's buying are the mugs. So the cost of the mugs is $10 each. She's also buying 3 of those. And then 10 times 3 gives me $30. Now that's everything she's buying. She's buying shirts and mugs. So for me to find the total amount of money she pays, I just want to add the 2 things she's buying. So our total amount of money she's spending is the $45 on shirts plus the $30 on mugs. That's going to leave us with, she spent a total of $75. So the last part, how much change should she get? Well, we want to take the money she has, subtract out the money she spends, and that'll tell us the change. So I had it all lined up. Can I fit it? So to figure out our change, we're going to take the money she has, subtract the money she's spending, and that leaves us with, she should get $25 in change. So it's kind of nice that it ended up being on the answer line. The answer would be, she gets $25. Now remember, part of this question is coming up with an equation to represent that. What we've got now is 4 different equations. And that's not what they're asking for. There's a way to represent this entire story with just one single equation. And the way that you do that is using order of operations. It's figuring out how you can write all the math we did, this line right here, how you can write it all together using addition, subtraction, multiplication, division, exponents if we need them, parentheses if we need them, using all of that to make one single math problem. So looking at this, one way we said we can do that is doing the math first and then using our math to help us figure out how to write it. So if I come over here, the first thing I wanted to do is I wanted to figure out the cost of shirts and mugs. So I'm going to just start off my equation by saying, okay, she had to figure out the cost of shirts. She had to figure out the cost of mugs. And then once I had both of those, I added those two things together. So right now I've got this is the cost of shirts, this is the cost of mugs, and I want to add them together like that. Now the last part was once we figured out the total amount of money she's spending, that's what I've got right here, right? This is the cost of all the shirts plus the cost of all the mugs. That's her total amount of money she's spending. We took the $100 and we subtracted all the money she was spending. Notice in that last line, I had my 100 first because that's the money she has, and I'm subtracting all the money she's spending. The money she's spending comes second. That's important because when we go to write our equation, that 100 needs to go at the front of it. So I'm going to have my 100 here, and then I want to subtract the money she's spending. The biggest mistake for problems like this is students say, okay, subtract the money she's spending, we're good to go. There's a problem with that. Do you know what that is? Let me back up a second. We said we want to subtract the money she's spending. What here that I've written is the money she's spending? Well, the money she's spending is all of this together. Notice how I'm circling all of that? I'm doing that because if I just write it like this, that isn't saying I want to subtract all of this. It's saying I want to subtract this, the cost of our shirts, and then add the cost of the mugs. It's not saying I want to subtract everything. I need to add something to what I've got written down right now to show subtract everything. And that something is parentheses. When I add in those parentheses, now it's saying she's got $100 she's brought to the store, and she's subtracting everything here, and that everything is the money she's spending. This is one strategy you can use for this problem. Another way is instead of doing all these steps over here, some people like to just map out the plan for the problem. What I mean by that is writing it with words first. If you're a word person, this might be a good strategy for you. So notice our strategy for figuring this out was we were going to take the money she has and subtract the money spent. That's our plan, right? Well, the money she has is $100. So I'm starting with $100 and I want to subtract the money she spent. Well, what did she spend money on? She spent money on, what were the two things? She spent money on shirts and she spent money on mugs. So the money she spent, I'm representing that by saying shirts and mugs. And then from that, you could fill in some of the numbers we had over here. Now this is one option for this equation, and I do want you to know there are many ways you could actually write this. This is one way, and I like this way because it's showing we're subtracting the total amount of money spent. Another way you could say this is she's got $100, she's subtracting the cost of the shirts, and she's also subtracting the cost of the mugs. These two things mean the same thing. I'm subtracting the cost of everything. That's the same way of saying I'm subtracting the cost of the shirts and subtracting the cost of the mugs. So this is another option. The last option you could say involves doing this math a little differently. So when you pause the video, when I have students in class, at least this is the most common way I see students do it, but there's actually another way you can do this. Instead of saying the cost of shirts and the cost of mugs, you can figure out how much you're spending on one person. I could figure out I'm spending on one person. They're getting a shirt and they're getting a mug. So one person, you're spending $15 on the shirt, $10 on the mug. One person costs $25. Well, she's buying it for 3 people. So once you've got the cost of one person, you could say the cost of 3 people is 25 times 3, which gives you 75. Notice that's the same thing we've got here. So if you were thinking about it this way, I think the last way you could write this is we're starting off with $100, and then instead of saying we're spending $15 on 3 shirts and $10 on 3 mugs, we could say we're going to subtract for 3 people the cost of a shirt and a mug. This is the last option. It's still using parentheses like this, but it's just written in a different way. All 3 of these would be perfect answers. All 3 of these end up giving you the same answer if you go through using order of operations to simplify it. It's really just a matter of how you think of the problem. And it's interesting as me, as your teacher, when I look and see like, oh, like this student was doing this, so that must be how they were thinking through doing the math. But this student might have thought through it this way. At the end of the day, everyone's getting $25 for change. We talked about a lot with this problem. I've got one last example here. Okay. The last one is about sports. It says, in football, a touchdown is worth 6 points. The Broncos have scored 2 touchdowns and the Colts have scored 3 touchdowns. The Dolphins have scored half as many points as the Broncos and Colts combined. How many points did the Dolphins score? Again, I'm going to have you go ahead and come up with the answer. And if you want, see if you can also come up with an equation. Go ahead and pause the video and try to do as much as you can with this problem. All right. I think for this one, I'm going to try doing the other strategy first, just so you can see both options. So the other strategy, remember, was kind of coming up with a plan using words to represent everything first, and then afterwards filling in numbers. So the question for this problem is asking how many points did the Dolphins score? We're trying to figure out how many the Dolphins scored. What do we know about the Dolphins? Well, we know the Dolphins scored half as many points as the Broncos and Colts combined. So I'm going to write down exactly that. I know the Dolphins, the amount of points they got equals half as many as the Broncos and Colts combined. That word combined means you're putting them together, means you're adding. So the Dolphins got half of what the Broncos and the Colts got together. So I'm trying to figure out what the Broncos and Colts got together, and then I'll want to find what half of that is. Well, what did the Broncos and the Colts get? Well, the Broncos scored 2 touchdowns, and we know each touchdown is worth 6 points. So the Broncos, they got 2 touchdowns for 6 points each. What about the Colts? The Colts got 3 touchdowns. So I'm going to say for the Colts, they got 3 touchdowns for 6 points each. We already know from before that we're going to combine those 2 things. We're going to add the Broncos and the Colts together. So I'm just going to copy down that plus sign there. So we're trying to figure out what is half of all of this. What is half of all of this? I keep emphasizing that all of this because we're finding half of a lot of stuff there. We're going to need parentheses around that. The last part is finding half of something. There's a couple different ways you can think of that. One way is using that fraction. We learned if you're trying to find a fraction of something, that word of means multiplication. So one option for this problem is saying half times 2 times 6 plus 3 times 6. Another way of finding half of something is dividing it by 2. If, I don't know, if we were buying a pizza that cost $10 and we each were paying for half, you could think of it as like, well, what's half times 10? But lots of times people, instead of thinking half times 10, they say like, oh, the pizza costs $10. We're dividing it by 2 people. So we're going to do 10 divided by 2. So this is one option for that equation. Another option would be dividing how many points the Broncos and Colts got together by 2. If I'm dividing this by 2, that division needs to come at the end. So another option could be 2 times 6 plus 3 times 6. I want all of their points, and I want to divide it by 2. You could write it like this. Another way you could write it, instead of using that division sign, remember we've learned fraction lines can mean division. You could put it like that if you wanted, or you could write 2 times 6 plus 3 times 6. I want to divide all of that, so notice that fraction line is going all the way across, by 2. Similar to that last one, there are a lot of different ways you can write this, and it's not as fun when there's not students in the room because usually I'm hearing all these different ways from you guys. But I'm trying to put as many as possible up here on the board just so you've got an idea if what you had at home is correct. For all of these problems I've written, this one and this one and this one, when we go to actually do the math, all of them are going to start off by doing this part right here. Finding how many points the Broncos got and finding how many points the Colts got. Finding how many points Broncos got, how many points Colts got. This last one isn't using parentheses, but remember that idea of like doing grouped things first. All of this is together at the top of that division problem. We're going to have to figure out what that equals before we can divide by 2. Either way, we're going to have to start off by figuring out how many the Broncos got. And I do that by doing the 2 touchdowns times 6 points each, which gives me 12. So that's one of our steps. And then the other step is figuring out how many points the Colts got. The Colts got 3 touchdowns times 6 points each, which would be 18 points. The question, remember, says the Dolphins scored half as many points as the Broncos and Colts combined. So the next thing I need to do is figure out how many total points they got combined. To do that, I want to add these 2 things together. So 12 plus 18, that gives me a total of 30 points. And then the Dolphins scored half as many points as them combined. So I want to find what half of 30 is. We've talked about a couple different ways you can think of that. You can just think of half of 30. You can think of it as 1/2 times 30 over 1. You can think of it as 30 divided by 2. All of those ways, you're going to end up getting 15. So that answer, how many points did the Dolphins score? They scored 15 points. I did it like this because remember, this is the other way, is you can do all the math first, find your answer, and then use what we've got written over here to help you come up with a way to write the problem. If you've already got this part first, so let's say I started off by coming up with this expression here, then you could just use this to come up with the answer. So instead of doing all the math like this, if I already had something like 1/2 times 2 times 6 plus 3 times 6 written down, I could look at this and use what we learned today about PEMDAS to help me do the math. If I'm looking at this problem, I would want to start inside my parentheses. Now notice there's a lot of math going on inside the parentheses. Treat it like a little mini problem. I've got multiplication, addition, and multiplication. So using this, I would want to do the multiplication first, get answers, and then add. So here it would be, let's do the multiplication first, 12 plus 18. I'm still not done with my parentheses because there's still more math to do. So my last step could be 12 plus 18, which gives me 30. And then my last step, half times 30, so half of 30, that equals 15. We're getting the same answer that we got over there. Like I said, the focus of this lesson, especially today, is how you take story problems like this and represent them with a single equation, which can be very challenging, especially when we lots of times just think of them as a bunch of individual steps instead of one single step written using order of operations. I'm going to erase all of this, and I've got 2 for you to try, and that will be the end of this lesson. Okay. We've got, the first one says, Melissa, Paula, and Ashley go out to eat. They order some appetizers for $11 and a pizza for $16. If they want to split the cost of the meal, how much should each person pay? Go ahead, pause the video, try both parts. All right, I'm gonna really focus on what the equations for these look like. We're trying to figure out how much each person should pay. We want to know the total cost, and then we're going to divide the total cost by how many people there are. And here there are 3 people. That total cost was the $11 for the appetizer and the $16 for the pizza. So one possible equation could be saying I'm adding my $11 for the appetizer, $16 for pizza. I'm putting parentheses around that to show this represents altogether the total cost. And then we're going to divide it by 3 people. You could write it like that. You could write it like 11 plus 16 divided by 3, showing something similar. This top part represents our total cost that we're dividing by 3 people. You could write it as 11 plus 16 and then use that division line like that, divided by 3. What you can't do is write 11 plus 16 divided by 3. Do you know what's wrong with that? There, that's showing you're only dividing the cost of the pizza, the $16 by 3. That's not showing that you're dividing everything by 3. The answer for this would be 27 divided by 3, which is $9 each. The last one, ooh, look, fractions, so fun. Remember, we practiced fractions yesterday. And this one here, we've got Hannah walked 2/3 of a mile each day for 4 days this week. Carrington walked 1/6 of a mile each day for 7 days this week. How many more miles did Hannah walk than Carrington? Again, go ahead, try coming up with an equation to represent this, an answer for this question. Pause the video and then come back. All right, we're trying to figure out how many more miles Hannah walked than Carrington. We know Hannah walked more, so if I'm trying to find out how many more miles, I want to figure out how many miles Hannah walked and subtract how many miles Carrington walked, and that'll give me my answer. Well, how many miles did Hannah walk? She walked 2/3 of a mile each day for 4 days this week. So we're gonna take what she walked in one day and multiply it by the 4 days. So for Hannah, I'm gonna say she walked 2/3 of a mile times 4 days. You could also say 2/3 of a mile on day 1 plus 2/3 of a mile on day 2 plus 2/3 of a mile on day 3 plus 2/3 of a mile on day 4. There's nothing wrong with that. But if we're using addition for that, that's gonna make your problem even bigger than it's already gonna be. So we've got Hannah is 2/3 of a mile times the 4 days. Carrington, similar, he is 1/6 of a mile times 7 days. I wrote it like that. You could also write it with parentheses if you wanted to. It is up to you how you want to do that. But the very last part is just taking what Hannah walked and subtracting what Carrington walked. That right there would be your equation. The answer for this is going to use some fraction multiplication and subtraction. When we multiply here, remember you're going to want to think of that 4 as 4 over 1. So when you multiply that, you end up with 8/3. We're going to subtract 1/6 times 7, 7 over 1. So that is 7/6. One of the things we learned about adding and subtracting fractions is those denominators need to be the same. So right now I can't subtract yet. I'm going to need to change them to have the same denominator. Usually the way we try is we take the one with the smaller denominator and see if we can multiply it by something so that they end up having the same denominators. This one stays 7/6. This one, 2 times 3 gives me the 6 I want, and then 2 times 8 gives me 16. When we go to actually subtract, that denominator stays the same. And then our 16 minus 7 is going to give us 9/6. The last part is, can you simplify? Here I see both of these numbers I can divide by 3. That is going to leave me with 3/2. So we could say Hannah walked 3/2 of a mile. I am very happy if you get to 3/2. Some people know how to change that into a mixed fraction, which means you've got a whole number and a fraction. 3/2 is the same thing as 1 full mile and 1/2. So if you said that as your final answer, I do want you to know that's also correct. This is kind of where I'm saying, like, let's get to this point here to 3/2. But if you take it a step further, that is amazing. And what's also amazing is this was the last practice problem. I'm hoping you're feeling a lot better of order operations, specifically looking at word problems and representing them, since that's what was the focus of this lesson. Starting tomorrow, we're going to start getting into some of the new stuff we get to learn in pre-algebra, so get excited. See you guys tomorrow, hopefully. Bye.